Hi guys, Rick Malava here with just a short discussion on what manifold and non-manifold geometry is in Maya. Basically speaking, manifold geometry is something that can be manufactured following a specific set of mathematical rules. More simply stated, manifold geometry is something that can be unfolded into a flat surface with all of its normals facing in the same direction. And there's one additional rule, and that is if you have faces that are attached to one another, they must be attached by an edge and not by a single point. So with that being said, there are three types of non-manifold geometry in Maya. The first is the T-type non-manifold geometry, and in this particular case we have three faces here, all attached and sharing a single edge. So you can't have more than two faces sharing a single edge. That would be non-manifold. If there's no way that I can unfold this into a single flat piece. Another way to think of it is if I was to put my hand on this face and run it up to this edge and then run it up to this face, if I turn my normals on by going to display polygon face normals, you can see that the normal of this face is pointing up, the normal of the face here is pointing in the positive x direction, and the face of this, the normal of this face is pointing up in positive y. Now, in order for me to get from this edge to this edge without lifting my hand off of the surface, my hand is facing, touching this face, and the normal is pointing toward my hand. As I go up this face, the normal is also pointing towards my hand. But I can't get from this edge down to this edge and over to this edge without putting my hand down this face. But this face's edge, or this face's normal, is pointing away from my hand. So basically I can't get across this whole surface always touching a face with its normal pointing toward my hand. So you can't unfold this geometry into a single flat piece. The only way that I could fix this is to separate this face from these two faces, and then I would have manifold geometry again. The other type of manifold geometry is the bow tie type manifold geometry. The other rule for manifold geometry and unfolding a surface so that it's flat is that all faces must be connected by an edge. In this case, you can't have two or more faces that share a common vertex. And this is often called the bow tie non-manifold geometry type. So you can see here why it's called that. It looks like a bow tie. If I go to vertex mode and I select this one vertex, you can see there's a single vertex there that's being shared by two faces. Pardon me for coughing. And so that's the second type of non-manifold geometry. And then the last type of non-manifold geometry is the flip normal type geometry. It's actually very similar to this geometry here in that I can't get across this entire surface or unfold this surface flat and have its normals all facing in the same direction. This is one of the hardest non-manifold geometry types to detect, because if I didn't have border edges turned on right now, this would just look like a simple polygon surface made up of two polygonal faces. And you'd wonder why it's being flagged as non-manifold. But if I turn on once again the face normals by going to display polygon face normals, you can see that the normal of this face is pointing up and the normal of this face is pointing down. So I can't run my hand from this edge to this edge to this edge and always touch a face with its normal pointing up towards my hand. There's no way to unfold this surface into a flat surface and have all of its normals pointing in the same direction. An easy way to detect this, one of them you see right here, I usually go to my settings and I turn on display border edges. So if I go to settings and preferences, and you go to polygon settings, I turn on display border edges. So right here, border edges turned on, and I give my edge width 4 pixels so that they're a bit broader and you can see where the border edges of the surface are. So although this face or this polygonal surface has two faces, and if I go to vertices, they're sharing a common edge. There's one vertice there and one vertice there, and even if I go to edge mode, you see it sees a single edge here, but yet it's showing this edge as a border, and that's because you can't have a closed border between two faces if their normals are pointing in opposite directions. So this is a clue that you got a problem here. The other way that other thing that can help is by turning on your lighting and turning off two-sided shading. And when I do that, it becomes even more evident what the problem is. Any surface with its face pointing towards me, I'll be able to see its shader. Any surface with its normals pointing away from me, I can't. So if I go underneath this object, you can see I can see the shader on this side, but I can't on this side. Whereas I can, when I look at the top, it's flipped. I can see the shader on this side, but not on that side. So there you go. Those are the three types of non-manifold geometry in Maya, and basically in order to be manifold, a surface must be able to be unfolded and into a flat surface, and the other rule is that any faces that connect to one another have to be connected through an edge, not a vertex. So there you go. Now, more importantly than understanding what non-manifold geometry is to understand how do I actually detect it and correct it in Maya. Well, Maya gives you a tool to do that under the mesh options called Mesh Cleanup. If I select all of these guys and you go to your polygon menu, Mesh, and go to Cleanup, you'll bring up this window here. You can also get to this by holding down your space bar and bringing up your marking menu and going to Mesh Cleanup, or you can hold down the Shift key and press the right mouse button and you can go to Mesh Cleanup right here. So that brings up this window, and by default, if I reset everything back, Maya will actually try to correct and clean up the matching polygons, or you can just have Maya highlight the offending polygons to you and the offending components as well. This section down here we won't worry about in this discussion, because all it really does is helps you to detect, for instance, faces with more than 4 sides or n-gons, faces with holes in them, non-planar faces. Those are the 3 things that I like to look up the most. And then this is the section that we're interested in. By checking this box, which is normally off, the one that says non-manifold geometry, we can have Maya highlight any components within our objects that are giving non-manifold geometry or causing non-manifold geometry. Another couple options that are always helpful to turn on is this lamina faces. Those are faces that are right on top of one another. For instance, you accidentally duplicate your entire model and it's sitting on top of itself, or several faces within your model that are sitting on top of themselves. This will help you find those and you can get rid of them. The other thing is looking for edges that have 0 length. If you've got an edge with 2 of its vertices just stacked right on top of each other. And then finally the one is faces with zero geometric area. This would be a face made up of 3 or more vertices where all the vertices are stacked on top of each other once again. And for both of these you can set a tolerance value. And then this last one here, faces with 0 map area, they deal with UV space, where you have UVs that are co-resident with one another, and I usually don't worry about that too much, so I just turn these 4 options on. And with all of these objects selected, if I hit apply, you can see Maya highlights all of the, or goes to component mode for all of these, and if I go to object mode, you can see it's highlighting the components that are causing the problems. So it sees these vertices here, this vertice here, and these vertices here as a problem, and it's flagging all of these objects as being non-manifold. To show that that's actually working, if I go here and create, let's say, a valid object like a polygon cube, and I take it, and move it down here, and now I select all these objects again, including the polygon cube, which is fine, and hit apply. You see it's only going into component mode for these objects up here. So with that said, let's see what Maya does to actually correct this geometry. So once again, I'll go to object mode, and I'll select all these objects, and then we'll switch from select matching polygons to clean up matching polygons, and then hit apply. And now it goes to component mode for everything again, including the object that's fine, but if I go to object mode, you see there are no components selected, so it's cleaned up the non-manifold geometry. And the way that it did it for the T-type non-manifold geometry, if I go in here, this is a single object that's combined, but you can see that I have a highlighted border edge here, so this means that this surface and this face here aren't attached anymore. So if I go in and separate this object, you can see all it did is it split away that face. So now I have one surface that can be unfolded into a flat surface with its normals all facing in the same direction, and then a second face. It just separated them. And so if I go to the situation where we have 2 faces sharing a single vertice, you can see what it's probably done here is it's separated these into two separate objects. And sure enough, if I select that vertex, there's now two vertexes where there was one before. So instead of all we have here now is two faces that just happen to have one of their vertices co-resonant. And to show that, I can once again go to object mode, separate these objects, select this face, and pull it away. And then the final situation is the one where we had our normals flipped. And you can see what Maya did here is it just came around and picked one of the faces and flipped the normals so they're both facing in the same direction. If I look at the bottom, you can see it's black because I have two-sided lighting turned off. And if I come to the top, you can see I can see the shader, plus I can see the little face normal vectors showing me that the faces are both pointing in the same direction. One of the reasons why you might want to use the show me select just matching polygons before you actually let Maya clean it up is you don't have any control over, for instance, which of these faces Maya is going to flip. So if you use the first option, or use the option to just show the offending surfaces, you have the option of deciding which face to flip rather than Maya doing it for you. So there you go. That's a short discussion of what manifold and non-manifold geometry is. There's three types: the T form, the bow tie form, and the flip normal form. And using the mesh cleanup tool with the non-manifold geometry box selected is the way to clean it up. Thanks, guys. I hope you found this helpful.